One more. Actually, 6 point. No? 1,0, 0, 0,0,1, and 1,0,1. No? Okay, let's do that. First of all, plot the point on the three-dimensional space because we have three components, no? X, Y, Z. 0,0,0 is the origin. That one. 1,0,0 is one here. Okay. 0,1,0 is this. 1,1,0 is on the, here. Suppose the same distance here and the same distance here. This is this. 0,0,1 is. I make a mistake here, right? Yeah. This point is this point because it's a Y, and this point is this point. One more. When we have 1,0,1 here, another point here. This is this. And we have another, no? Oh no more. 1, 2, 3, 4, 5, 6. Okay, we connect it with the segment line. And this is our solid. Our solid have here. Oh no. Our solid have a plane here, another plane here, another plane in the XY at the base. This is my solid. Okay, of course, this is a prism. We can compute a volume without too much multiple integral. We can use a geometry, no? Okay, but let's do it in the last part. Now my objective is applying the multivariable calculus. Okay, so now I need so day one you are doing using double integral, I suppose, no? Yeah, double integral. So in the double integral, suppose we are using C simple. Well, no, double integral. So double integral is double integral. The integrand function is the z value of this. So si I suppose from this to this, this c value, okay, I have no idea. This c value of this plane, dA. And the region is obviously is the projection, no? This is 3D. Entonces en 2D view, for example, for plan, es obvio que this is elementary square. Every h is 1. Okay, entonces set out this double integral is super easy. Okay, super easy. The complicated part is not complicated, but a little bit we knew is determine the z. It's the z of this plane. Okay, we can obtain in different way. You can obtain use intuition. For example, intuition is suppose another view. It's a 2D view, and this is all the 2D view. This is X and this is C. Pero no, wait. No. This is Y. This is Y because I suppose que this plane is along the x-axis, and the equation of this plane, okay, by the way, is something like that: ax plus by plus cz equal to 0, no? The standard equation for the plane. X is missing. How do you know it's missing? Because this plane is along the x-axis. Therefore, I suppose that this line is this line. Yes or no? It's a 1. It's a 1. And the equation of this line is piece okay for us. Is C plus Y equal 1, no? And that's it. Entonces, what is the famous sig I need to find? Que es this. And this theta, no? Is C equal 1 minus Y. Are you agree or disagree? Do you like that way or no? And you know another way to find this. This is a shortcut to do fast. But maybe you are not too more familiar with this way, no? Opinion. What is the traditional way that we are using to find the equation of any plane when you have 3 points? You remember or you don't remember? Okay, I talk to you. Any answer? No, I don't remember, Professor. Okay. Oh, give me a clue. Nobody? I don't remember. Okay, David. Okay. Well, one possibility is we're using and the other test. Exactly. Okay. He say Max. Max say A x minus x null plus B y minus y null plus C minus C null equal to 0. Que es la que da product, ¿no? Entonces, x null, y null, and C null is arbitrary, totally arbitrary point. Suppose I take this point. Suppose you take either. Pero suppose que I take this, que this is 0,0,1. Entonces, x null is 0. Y null is 0. And C null is 1. And what about ABC? Who is ABC? A, B, C. How you find that? And what means ABC in the plane? A ver, I don't want you to make a noise. I don't want you to help me to solve the problem, no? A ver, let me see. Who make a noise? Heiner, ¿no? No. David, ¿no? Emiliano. No more noise. Okay. Nobody can help me. My question is only who is ABC. What represents ABC?
The normal vector.
A normal vector. Very well. A normal vector. So we have a vector here. We have a vector here. Okay, it's called a normal vector. We call it like that. Okay, this is ABC. How you find normal vector? What is the possibility that we have in my hand to find a normal vector? Remember, normal vector is a vector perpendicular to the plane. No? And no es the first time que you apply some operation and vectors, with vectors, sorry, to find another vector que es perpendicular, no? So this is not new for us. What is the operation que allow me find the perpendicular?
Cross product.
Exactly, cross product. So now, suppose que you take one pivot point, is this, and you take, using the point, of course, one vector in between 2 points, is super easy. And you determine another vector in between a point, using the same common point, no? The pivot, you take the point. So for example, the A vector, let me call A vector, this vector, is 1, 0, 0. This is super easy, right? You know, because the coordinate, that point is 1, 0, 1, no? And you're subtracting the component 1 minus 0, 0 minus 0, 1 minus 1, and you get the vector B. Likewise, you get the vector B. Who is the vector B? That vector. Okay, that vector is 0, 1, negative 1. You obtain, because that point is the point 0, 1, 0, and you're subtracting. 0 minus 0 is 0. 1 minus 0 is 1. 0 minus 1 is negative. Okay, and after that, we are doing the cross product. The cross product A cross B. The format for the cross product is something like that. Okay, I'm solving this cross product, and the answer is, you know, I want to skip that part. And this is my famous ABC. And this is my famous ABC. So I come back to this equation. I know that A is 0 is logical, because it's a plane, it's along the x-axis. The x part do not participate in the game. And B and C are 1. So now is 1 parenthesis y minus something. But remember, the pivot is this, plus 1 c minus something, que c is 1, look, equals 0. Okay, now y, that part is just y, plus c minus 1 equals 0. So c is equal 1 minus y. Same answer that we obtain with the shortcut. A little bit imagination, no? And a little bit imagination. Everyone follow me? Do you understand this idea or no? This is not new for you. Okay, now we come back to the
Professor.
Please.
What point?
Either point. Either point. You take one point.
Can you use any point?
Any point on the plane. On the plane. And the plane you want to discover. So to find the equation of the plane, you need 3 points. On the plane. You take one a pivot, and you determine 2 vectors in between these points. Make a cross product, and when you finish the cross product, you have in your hand the normal vector. Okay, and the formula que you give me is A parenthesis x minus x null plus B blah blah blah. You plug in x null, y null, and c null, the point que you consider like a pivot, right? Clear or no?
Clear.
Excellent. Now. I set out the double integral. The double integral. Okay, now, well, es obvio que the integrand function es C, ¿no? Pero en this case, 1 minus 1. No C because we are working in double integral. Entonces, now your integration may be in this direction que, you know, que I like so much. Entonces, integration in this direction, this is the region. Okay, entonces now, the limit is constant, it's super easy, 0, 1, 0, 1. Okay, and this is the volume. Okay, you are doing, first of all, the first part, que es this integral. Let's do it. Out. Okay, I copy this integral. Okay, this is super easy. Antiderivative 1 is y. Antiderivative minus y is minus y squared over 2, no? Evaluating between 0 and 1. Es obvio que the answer es 1 minus 1 half es 1 half. Entonces, plugging in the second integral, que es the integral en dx, es 1 half dx. Es obvio que antiderivative dx is x. Don't forget 1 half. Evaluating between 0 and 1, the answer is 1. And this 1 half represents the volume of this solid, que es a prism. And this is no surprise. Using elementary high school geometry, I can see that this is a triangle. And this is another triangle. And the area of the triangle is 1 half. Base, que es 1, and height, que es 1 half. But in this solid, you multiply the area of the hypothetical base of the prism. And I consider this triangle like a base, according to the symmetry of the figure, no? Multiplied by height. And height is also 1. Now the volume is the famous formula, no? Area of the base of the figure que you consider the base multiplied by height, pero es que height es 1, es that distance. Entonces your multiplication, 1 half times 1 is 1 half. Okay, of course, in the test I want that you are doing no but geometry, no? It's a verification, double checking something, no? You are doing by traditional method in the double integral, no? Because the problem say, well, the problem do no specification or anything. Okay, double integral. Any question? Do you understand this or not? It's weird, it's confusing. Please, it's a moment, interchange information.
Professor?
Uh-huh.
Where can you shade the area that you found with the double integral?
Absolutely, yeah. When you consider, yeah. The answer is yes. When you consider.
I'm just asking if you can shade it because I'm not sure like where it is.
Okay. Basically, this double integral in the problem give me volume. It's correct for you, right? The reason que ese volume is because
yes,
the integrand function is not 1. It's 1 minus y. Que by the way, represent the height of the plane. However, you can using double integral to compute the area if you consider the integrand function 1 in the region, and you get exactly. It's the same idea that you are doing in Cal 1. But in Cal 1, when you are doing area under the curve, default, you consider a strip. And when you're extending this strip under the integration, there's only one integration, you get the area. However, in multivariable calculus, you have the same problem, suppose. But you consider that dA is a small rectangle. So you are doing two integrals. One integral is stretch this in this direction, and another integral. And this is the same. Only the consideration that the integrand function is 1. Si the integrand function is no 1, entonces another meaning. Cool?
Cool. And can we do this problem just with geometry on the test?
Oh,
If we had a
no, hello. No. We practice the multiple integral. So, no.
Okay.
This is another way, because maybe I change the test. No.
Yeah, and
No.
it's just a good way to confirm our answer.
The answer is the same. O sea, en matemáticas, si you are doing well for two different way, you get the same answer. It's obvious, no? Matemáticas exact sign. Clear, mister?
Clear.
Sure. I feel que you have one secret doubt. No?
No, very clear.
Okay, super cool. Let's move on to another guy, another students. Remember, the participation is super important for me. When I, for example, in the last moment, I decide you overall grade. The student can participate, supposed to get 80, 88, 89, 85. For me, I put A for sure. Okay? And the student get quiet all the time. I don't know. Who are you? You never participate in my lecture. Okay, 7. 7 is set up, but not set up. We are doing computations. The triple integral using cylindrical coordinate for finding the body of the solid bounded by the paraboloid. Okay, nice. I appreciate so much this help. Okay, paraboloid is equal z equal 1 plus 2x squared plus 2y squared. Professor, I look in the test and I thinking que the are issue. Bueno, you email me. No. You email me. Si you see some problem, let me know. Communicate by email or when the class is over. I don't know, we are solving question number 7. Don't interrupt me, please. Okay, entonces, okay. We have paraboloid, it's obvious, right? I investigate the more clear what is the shape of this paraboloid. You see, open up, open down. And the plane, C equals 7. No? This is my solid T, no? My solid T. Okay, so I try to do my best. Remember, identification, paraboloid plane. I try to do my best in 3D. I know it's a little bit hard, but I have to. And one more thing. Oh, I forgot the most important. The first opta. Okay, no negative part, only positive part. So not necessary extending in this direction. No. Erase that part. La corner. Entonces paraboloide. This paraboloid, I can see the coefficients are the coefficients in front, no, the square part is positive. That means this paraboloid open up. Okay, and we have one famous z-intercept n1. So one here. So when the x is 0 and y is 0, es obvio que c es 1. Entonces this is super important point 0, 0, 1. Cool. And this is 1. and the paraboloid approximately open in that direction, right? Now, in the top part, it's bounded by the c equals 7. Suppose 7 here, I don't know. And we have this. So the solid is bounded in the top part for the plane c equals 7. In the lateral wall, at least in the first octane, is the paraboloid, but is also bounded by the plane x equals 0 and the plane y equals 0. Okay, actually this guy is no completely rounded. No, this is not rounded. This is 3D picture. I have some idea, but to complete the picture, maybe I am doing the floor plan. It's in the first octane. Here I have 1/4 of circle, no? And by the way, I have no idea what is the radius. Pero at least, using my imagination, we have that region. We have that region. Okay, so far it's clear. So far it's clear. Okay, let me try. Remember, as always happens, to determine the radius, we need to intersecting the plane and the paraboloid. So now, you consider that the C is the same value, it's 7, is equal 1 plus 2x squared plus 2y squared. This is the intersection in between paraboloid and plane. Okay, now let's try it. Entonces, 7 minus 1, que es 6, is equal to x squared plus y squared divided by 2, whole thing. The equation stays like a 3 equal x squared plus y squared. Wow, fantastic. This quarter of circle, the equation is x squared plus y squared equal 3. The super fantastic conclusion is the radius is radical 3. So far, follow me? And they want, can you compute the volume, please? Using triple integral. However, an specification que es en cylindrical. Now remember, cylindrical is a combination, polar and Cartesian. It's obvious that the best way is using C symbol, in which you integration C from the Z of the paraboloid to the Z of the plane. Okay, now you complete the triple integral with the double integral in the region R and the projection onto the XY axis. Okay, ready. I saw triple integral, 1, 2, 3. 1, 2, 3. Es obvio que the integral function is 1. Guys, if you want, you put 1 or no. I don't care. This one is only symbolic way to say que es the triple integral become like a volume when the integral function is 1. And the order of the integration is dz, dr, que of course, don't forget the Jacobian. It always is the same. R, dr, d theta. Now C go from C of the paraboloid. C of the paraboloid is this. I want to copy again. So C of the paraboloid is the bottom part. C paraboloid to C of the plane. C of the plane is easy. It's 7. It's 7. This is easy. This is 7. C of the paraboloid, no, it's a variable. is 1 plus 2x squared plus y squared, but I cannot write like that because using variable of the Cartesian. Yeah, I changed my problem to cylindrical. In cylindrical, the variable que participate in this game is C, R, and T. Like a polar, no? Cylindrical is extension, pero it's easy because you factor out, for example, that 2, and you see que x squared plus y squared is r squared. Okay? And so I go to the C of the paraboloid, que is this, que is 1 plus 2r squared to 7. I finish the integration of the 3D, o sea, the C part, I finished that. Entonces I focus, I dedicate now to do the integration for the double integral in the region R, get this region R, but I need to set out properly the limit. And polar is super easy. I go, radio go from 0 to the radio, that is constant. It's 0 radical 3. And the angle go from 0 to pi over 2. 90 degrees, because it's a quarter of second. And this is my famous volume. Cool?
Professor,
Go ahead.
you put the integrand function as 1 because it equals volume when the integrand function is 1.
Suppose that the integrand function is no 1. I know that you don't understand very well this idea. Because you try to see beyond the idea. The idea is super elemental. Suppose that you have another function here. Now the interpretation of this triple integral is no volume. It's another thing. Another thing que depende de the nature of the integrand function. Si you consider que the integrand function is the density function, es obvio que the interpretation of this triple integral is a mass. Pero no, suppose more complicated. Suppose que you have, for example, suppose que this is equal density. And density not necessarily constant, because the body is, heterogeneous. We have, for example, one part of the in aluminum, another part is in wood. Those are different material, no? However, si you try to find, for example, the center of mass, entonces it's more than this. It's density multiplication by one variable, que es x. You want to find the moment with respect to the x-axis. So do you see the interpretation of the triple integral depende of the integrand function. So now you put 1, you eliminate one dimension in the problem. No? The problem is mass. So, si I see bueno, professor, what is the interpretation of triple integral? The interpretation is si you consider que the density function is arbitrary, it's a mass. Okay. However, si you consider that the mass is constant and equal 1, so you eliminate mentally one dimension of the problem. Now it's a volume. Okay? Similar idea. Guys, this concept is repeated anytime, every day in Calculus 3. And you see in the next chapter the same idea, but in another sense, in vector calculus. It's a little bit clear, mister, or no? Honestly.
Yeah,
It's beautiful.
And one more question was,
please.
How did you get the lower limit for the dz integral?
Look at that. It's this distance. It's that C paraboloid to the C of the plane. So see, let me make a zoom. In our solid, it's bounded in the lower to the C of the paraboloid to this. It's bounded in this. Outside, no. Below, no. Above, no. It's bounded by this. So basically, that lower limit you obtain like a C value of the paraboloid, no? Que I did that. Copy. But unfortunately, we cannot put in the triple integral using x and y because I do a totally change of variable. I transformed this to the cylindrical coordinate in which x and y do not exist. I even I include here the Jacobian part. That this new integral is change variable, but this is like the most popular, no? Chain of variable is cylindrical, no? Make sense?
Yeah, but why wouldn't the lower limit be 1? Because I like it only goes down. I mean, like you know what I'm saying? Like I see it as it should be from 1 to 7 is what I'm thinking in my head.
No, 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 no. I agree with you. See, we have one plane here. We have another plane. This plane is c equal 7, and this is c equal 1. So this distance is constant anytime. However, this distance is not constant. 1 is this, 7 is this. I agree with you, but on this part, yes. But on this part, no. You see this is a small distance, and how you indicate small distance is a variable. And depending on the radio, in the origin, the distance is obvious 6 and 7 minus 1. However, when you go away of the origin, the distance decreases, no? And you consider variable. Make sense?
Yeah, so then
Uh-huh.
you just change the the first equation to polar.
Yeah, and that's it.
Okay.
Ajá, pero no es mecánica. You need to understand the thinking you are doing. You need to understand doing the picture in 3D que our solid is formed by two surfaces. The top surface is 7 and the bottom surface is the paraboloid.
And it changes.
Exactly. Ajá, entonces the height of this solid, well, is not
Oh,
constant. It's not constant. It's a
okay.
variable. Okay.
Because because it's bounded by z equals 7 and z
Uh-huh.
equals the
Uh-huh.
other function. But
Yes. Yes. Yes.
since we're switching to polar, we have or cylindrical,
Oh, no,
we
no, no, no. You switch into polar because when I doing the projection in the XY, I say, wow, it's a quarter of circle. So for me, it's much better. Suppose que I'm doing Cartesian is crazy. No, 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 impossible. Not impossible. Pero it's hard. Because, for example, si I integrate in this direction, I go in the double integral, I go from 0 to the y value of the circle is square root 3 minus x squared, right? Uh-huh. And after, when you open this, I go from 0 to radical 3. But you see, this is a little bit more complicated than this, no?
yeah, a lot
Uh-huh.
more.
Uh-huh. This is the beauty of the... Okay, so now, in that case, unfortunately, we cannot, we cannot, we cannot separate in three integral. Remember, you can separate when the limit is constant. So you are doing like an iterated integral, so step by step. Let's do it the first one. What is this? You copy separately, evaluating 1 plus 2r squared and 7. And the derivative is easy. Evaluate in between 1 plus 2r squared and 7. Actually, it's 7 minus 1 plus 2r. Entonces, 6, ¿no? Minus 2r squared. Something like that. Cool? So we continue. Now, you copy the second integral. You copy here from 0 to radical 3 of 6, and don't forget this r. You multiply this by r, 6r minus 2r cubic dr. Correct? But this is easy, no? That part, the complication is not the integration. Entonces es 6r squared divided by 2, actually is 3, minus 2r to the 4th power divided by 4. Evaluate in between, actually it's 3r squared plus r to the 4th power divided by 2. Evaluate in between 0 and radical 3. 0 es 0. Radical 3 no, radical 3 es radical 3. Entonces the answer is 9/2. When you plug in here, square. Finally, I come back. 9/2 is constant. Beautiful. The last integral. 9/2 dc. 9/2 is constant. Integral dc is dc. Value is pi/2. Entonces the answer is pi, 9 pi over 4. Do you understand very well this idea? Because I want to see. So in the lecture, normally I did the first time one triple integral by hand. Entonces you say, you know, Wolfram alpha. No, you can verify in Wolfram alpha if you want. However, in the test I want you are doing step by step. Okay? But I want put no, well, no, there's something complicated, but the majority no. It's not complicated, it's easy.
Professor?
Uh-huh.
With the Jacobian, what if you multiplied r in the beginning?
I suppose that you asked me last time this. I suppose that I don't know explain well for you. Okay, when you change the variable from the
my question is, can you multiply the r in the beginning and integrate with dz?
Yeah, but entonces, okay, good. I understand your question now. Okay, the answer is yes, but in the first level of the integration, you integrate with respect to c, and you consider r like a constant. Entonces, it doesn't matter que you include here inside. So suppose que you include here r, huh? Okay, but r is constant. Go outside the game. Boom, out. I put outside the game, R. Entonces now we have R here, and we have R here, and we have R here, and multiplication, and you get exactly the same of this. Cool?
Very cool.
Excellent. So, you know, my habit is ignore this R, because I know that this R is useless now in the first integral, but however it's useful in the second. Okay, es the integral que incluye dr. Super. This is a question I like. I like this question. Okay, now number 8. No more question in number 7. Guys, I dedicate my time to explain everything clear. Oh, I suppose get clear, no? In my mind, no? So now I expect good result in this test. I know get hard, and the other test is super hard. Okay? This is the last part. Okay, erase. Let's move on to question 8. Thank you for explaining. No. I enjoy it. I need students que ask me a smart question. No, so there are a lot of students I can find in my life. The student gets stupid, que say, no, I don't understand anything. So I have no clue. What is your problem? What is the part that you don't? Entonces I need to deduce. In the first line, no, I understand. In the second line, no, I understand. In the third line, no, I understand. You are doing, go directly to the point. Go, okay, what about this R? However, at the beginning, I don't understand very good. But I get the idea. Okay. Well, number 8 is triple integral using spherical. For finding the volume of the solid que lie within the sphere, and the sphere is given, and the plane xy and below the cone. Okay. We have a solid T. It's a question 8. We have solid T, and the solid T is formed by a sphere this is a sphere, and the radius of the sphere is obvious, is 2, and the center is located at the point 0, 0, 0. Okay, easy for me identification. And the cone is square root x squared plus y. Do you understand very well que es a cone? But this is a full cone or semicolon? Cone. It's a full cone or semicolon? And what part? The top part or the bottom part? Top part. How do you know it's the top part? No idea? You guessing? Or you understand very well? Because I assume the positive sign and the square root
is positive.
Yeah, absolutely. So si you omit the sign as default, you suppose que es positive. Okay, ready. We are doing the sketch in 3D. Using our imagination and common sense. Imagination is the most important, guys. It's the most important than que you memorize formulas. Imagination. Okay, entonces we have a sphere. But this is hemisphere also, no? Because this bounded indicate que sí es positive. So we have negative part here, right? But no negative part in the C. So we have a sphere like that. And the radio is 2. I try to do my best. I suppose it's not good. Well, so we have a cone. Here's the top part of the cone. I suppose it's like that. We have intersection here. Okay, I suppose using my imagination it's a circle. But I need to identification our solid. Because the problem is say we think sphere, okay. Above the cone. Above, within the sphere, above or below? Below. Si es below, in my opinion, you let me know si I'm good or no, esta part. Within a sphere and below the cone. No the traditional ice cream that we are doing in the class. No, is this solid. Of course, included that part, but see, I highlight this, I don't see very well. So this is the roughly 3D picture. Okay, not always is good. The only possibility to be good is in the algebra, but it's complicated. Because if you write, for example, your surface using the classical explicit formulas, so you don't see very well the solid because the surface overlap each other. And the only possibility is using the command surface I want to explain in the last chapter. Okay. Okay, because I need to the picture at least one. Suppose I'm doing, because I consider most important, one lateral view in which you have X here and C here. So we have the sphere, que the radio es 2, ¿no? Es 2, es 2 here, es 2. And the cone like that, I suppose. My solid then is in the upper. No, it's below the cone, no above. It's weird solid. Okay. No. It's enough? I suppose que no. I suppose I need another view. Okay, normally in spherical, I need two view. Two-dimension view. This is the famous XY axis. And then I see the circle of the radio 2 que represent the sphere. I have another circle que I have no idea what is the radio, pero represent the part. Pero it's easy because exactly as we are doing before, we're intersecting two surfaces. I take the equation for the sphere, que es x squared plus y squared plus c squared equal 4, and the equation for the cone. Entonces, to put together, I propose you square both sides. C squared is equal to x squared plus y squared. So there are too many ways to do that. Well, okay. One way is substitution. I copy x squared plus y squared plus no c anymore because I am in this view, and this view c is 0. Okay, so it's x squared plus y squared equal 4. 2x squared plus 2y squared equal 4 divided by 2, x squared plus y squared equal 2. Wow, and this is this equation of this circle. Okay, by the way, the radio is radical 2. And this distance is radical 2. And this distance is minus radical 2. Okay, and by the way, this plane, hypothetical plane, okay, cut off the, okay, here, this circle, okay, this circle is c equal radical 2. Because another manipulation, for example, of this equation, you're going to find the c, que es the level. Suppose que I'm doing the substitution different. You substitution x squared plus y squared like a c, and you have c squared plus another c squared equal 4. It's the same. 2c squared equal 4. C squared is equal 4 divided by 2 gets 2, and c is equal radical 2. Plus or minus, but plus or minus have sense only positive because minus in the other up down. y the restriction que sí es positive. Don't allow negative solution. Okay. So I have, wait. Entonces my solid, I forgot to say something, no? My solid lie in this region. Yes or no? Okay, this is my solid. Okay. Entonces day one, que you are doing the problem in spherical. And spherical, remember, is rho, phi, and theta. So spherical is a weird coordinate that have one radio vector and two angles, phi and theta. The theta you are familiar, because it's the same theta of the polar. Phi is weird. Phi is measured from z-axis. Okay, this is phi. Look. Okay. Okay. By the way, is 45 degrees, pi over 4. Why? Let me try to understand. You make a zoom. Do you see? Okay, this point is in xy. This point is radical 2, radical 2. Okay, and the hypotenuse is 2. It's over pi over 4. Right? Make sense? So now, if you set up
Professor? It looks like pi over 4 and makes sense that it's pi over 4, but how'd you know, like, guaranteed it's pi over 4? Just because tan equals tan theta, or tan of that would equal 1?
I want to explain. Look, you agree with me that this line, horizontal line, is radical 2? Yes or no?
Yes.
Because it's the same plane that we see in 3 dimensions, right? Mm-hmm. Actually, we have that triangle. Look at that. Bone, bone, and bone. This hypotenuse is 2. This segment is radical 2. And this segment would be radical 2 also, no? Using Pythagoras theorem, no? Let me try. I don't know. Suppose I don't know. Boom. Question mark. And question mark is square root the hypotenuse square get 4 minus the left square get 2. Boom, radical 2. Clear?
Clear.
Okay, so now let's focus in the important part. The important part now is the triple integral. 1, 2, 3. 1, 2, 3. 1, 2, 3. And the problem says it's a volume also. So the integral function is 1. However, always, 100%, we are using rho symbol. So the order is exactly the same in spherical. So you integration rho first. So this limit is rho. And after phi and after theta. And don't forget the Jacobian. Que the Jacobian is weird. It's rho squared sine phi. Okay? And cylindrical. And spherical, sorry, spherical. The first level of the integration is the rho. So to understand the rho limits, I go to this view. Rho is a radio vector from the origin to this. So always, fortunately, in my solid, The row go from 0 to 2. Yes or no? And that part is exactly. Okay, cool. Now, what about that part, Professor? No, that part is covered. Porque radio vector is in any direction. I bounded the direction when you define phi and when you define theta. So when you are doing this, actually, we are doing two parts simultaneously. The phi go from. I need help. What about phi? Que es the most complicated part to see. To cover our solid, go to 0 power 4. I suppose que no. I suppose que no, no? This is wrong. This is wrong, right? Phi. Remember, phi is the angle. Let's measure from the z-axis. So phi equals 0 is here. Phi pi over 4 is this. On the x-axis is phi equal pi over 2. And we why not moving to the other quadrant. Well, in this case, have no sense, no? But in another example, maybe yes. And opposite direction to the z-axis is phi equal pi. Makes sense, right? You understand phi or no? Therefore, my solid start here and ending here. Yes or no? So what is the limit in phi? Tell me.
Is it pi over 4 to 0?
No. No, the limit always is this a lower upper, no? Entonces, phi, in our solid, is the yellow part. Focus
Pi over
it.
4
Pi over 4, 2.
to 2 pi.
Second,
To 2 pi.
2 pi, no. Never, okay, phi never go to pi. Okay, phi go, the range of phi is from 0 to pi. Not 2 pi. It's pi. Because I see 2 pi. It's pi. So the maximum value of the phi is pi. Okay? Entonces, from hello, help me, guy, with the yellow part. What is the phi value in the yellow part? Nobody know? No? It's weird to understand phi. So this letter, the pronunciation is excellent, Davey. This is from pi over 4 to pi over 2. Everyone saw that or no? From this to this. When you extending phi from pi, start the top part of the our solid, and when you move into pi over 2 is the bottom part of the our solid. Okay. And what about theta? And what about theta? Theta. What about theta? Theta, to see theta, in my opinion, is easy in the XY plane. Because theta by definition is the angle. Theta by definition is this line. Theta is the angle measured from x-axis. Entonces I see que my solid look like in the fourth plan, like a ring, no? Like a ring. Therefore, Theta, go, 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 go. Help me. What is the limit of the theta? Now, this is easy. It's easy because you have a quarter of circle, or you have semicircle. Yes, exactly, 0 to pi. How do you know that? Because it's a circle. Bueno, it's a ring, pero it's a full circle, totally rounded, no? Si es quarter circle, it's from 0 pi over 2. Si es semicircle, 0 to pi. Okay, 0 to pi, theta, go, 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 0 to pi over 2. And here it's obvious que es 0 to pi. Pi. Si it's a full circle, it's 0 to pi. It doesn't matter if we have a hole here. Okay? Ajá, entonces now, wow, fantastic. This is super easy by hand. Because the limit is a constant, number one. And the function is totally separable. So you write 1, 2, 3 integrals separable. Okay, the first is rho squared d rho. Evaluating between 0 and 2. I consider only the rho part. Now sine phi, d phi, evaluate in between pi over 4 and pi over 2. And the last integral is always too easy, from 0 to pi, is d theta. And we compute separately, not necessarily in the same piece of paper. And now you put together a multiplication. Okay, do it. That part is rho cubic over 3. Evaluating between 0 and 2. This is 2 cubic is 8. 8 over 3, no? I suppose. Is the answer for this integral. The answer for this integral is also easy. Antiderivative sine is minus cosine. Cosine phi, evaluate in between pi over 4 and pi over 2. Okay, let's do in the evaluate. Evaluate is, I don't like this negative. I put outside the game, and you plug in here cosine pi over 2 minus cosine pi over 4. Okay, cosine pi over 2 is 0, and cosine pi over 4 is radical 2 over 2. We have double minus, so the answer is radical 2 over 2. And this is super easy. The antiderivative d theta is theta, or between 0 pi is 2 pi. Final answer, 2 pi times radical 2 over 2 times a over 3. The 2 is cancelled. The answer is then a pi radical 2 over 3. Boom. Any question?
Professor,
Uh-huh.
how you multiplied every integral, can we do that for the double integral as well?
Okay, normally the triple integral or the double integral is iterated by nature. However, I explained in some particular example in which the limit is a number, no variable, and the function, the integrand function is separable, we can compute separate, so you convert the triple integral in 3 integrals. Cal 1, cal 1, cal 1, 3 times. It's cal 3. But it's only in this scenario. Si the limit is a variable, if the limit is depending the phi or depending the rho, no, we cannot do. You can use it iterated. Integrate in the same order. Rho first, phi secondly, theta last. Cool?
Why do you have to go in that order?
Well. In this case, I don't know, geometrically, I suppose it's the most convenient order because
if you're just multiplying them, can't you go in any order and just
no, of course, but okay, one thing is set up and one thing is the computation. At the beginning, I don't know if the limit is constant or not. I copy the 3 symbol, bam, bam, bam. However, bueno, okay, I copy the Jacobian, okay, but you don't know. When you finish the setup, this guy is a number constants. Entonces I know que we can separate, pero si no constant, suppose another scenario, Okay, for example, here is 2 cosine phi, and this is 2. Okay, so now is iterated integral. So I need to compute this first. I'm putting it here, and compute the second, and compute the third. Okay, this idea is clear or no?
Yeah, so the limits have to be constant, and
Uh-huh.
then the integration
And
function
the
has to be
integral,
separable.
exactly. Excellent. That's the only possibility. But according to the magic,
And then
uh-huh, the magic,
otherwise we have to integrate it
otherwise
to the
no,
left,
otherwise,
right?
yeah, otherwise. So this is a particular, specific sum. But this is the magic of the spherical coordinate. So you are doing, for example, that problem in Cartesian or in cylindrical maybe. You never this possibility to compute super easy in the last moment. Okay? Because the limit is completely functions que depend on the variable. So we cannot separate. No, no, no. We are computing the iterate, and it's super complicated. Okay, this is the beauty. It's good that you see that. You see what is the idea? No, no, okay, I want. No, 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 I want. No, I need. I need to change the verb to spherical. And of course, the recommendation is surface like a sphere and cone is most convenient doing spherical coordinate. A surface can involve cylinder and paraboloid and plane also. In this case, plane also is cylindrical. And when you have just plane, well, entonces Cartesian, plane, Cartesian. Okay. Entonces, the beauty of the mathematics is that any way you select, if you're doing well, you get the same answer. However, what happens is you are doing using Cartesian, maybe you spend 2 weeks doing the problem case solving in 10 minutes in cylindrical, right? Right or no? Okay, cool. Now, I want to do number 9. Number 9 is evaluate the integral by changing the spherical coordinates. So one guy, not me, set out and one solid I need to investigate this triple integral. Entonces the integral function is xy, dz, dy, dx. Now this information is given because some guy, some students set up this triple integral in Cartesian, but my goal or my job is change to a spherical coordinate. It's doing, it's doing. So now, look, it's important, the order. This order is important. I cannot change this order. Therefore, it's obvious that this is C value and this is C value. So basically, so you can express it like inequality. C vary from square root x squared plus y squared to square root 2 minus x squared minus y squared. Okay? Always happen. You take separately this piece and you take like equation. Yeah, I try to manipulate only to understand this equation. You square both sides because this square root is not good for me. So c squared is equal to minus x squared plus y squared minus, minus. Therefore, when I move to the other side to putting a standard, I see putting alphabet, the order, x squared plus y squared plus c squared is equal to. Wow, entonces identification, clear, this is a sphere. And the student can set up this triple integral, I suppose in one moment is doing in your piece of paper a sphere. A sphere with the radial radical 2. Okay, this is the upper part. The lower part is, I convert one more time like equation. This, I copy, c equal square root x squared plus y squared. I am familiar. This is the cone. It's obvious, no? So you don't know, again, square both sides. You put in a standard. You put x squared plus y squared at the left hand side minus c squared equals 0. Wow, it's a cone. This is the cone, double cone. However, in my problem, I know que it's only the upper cone because when I express it in explicit form, and you take the positive sign of the square root, it's the upper. Everyone follow me? So I am ready. Well, almost ready to understand the solid. Okay, these students set out the triple integral. Okay, this is my three-dimension Cartesian coordinate x, y, and z. 3D picture. Okay, so we have a sphere. No, nobody say, well, no, I don't know. Well, no limitation, positive or negative. I don't know. This is a sphere. Okay, sphere. No. C positive again. By same reason, no negative part, because I take the positive part. And this radio is radical 2. Okay. And we have a cone. A cone is like that. And the intersection, so we happen is like that. However, the student can set out this triple integral is doing from the cone for the walk of the cone, bone to the wall of the sphere. Okay, cone is the lower part, and the sphere is the upper part. Okay, I understand a little bit. Therefore, I use my yellow color to highlight the hypothetic solid. It's a not full idea. It's a one hypothetic. Because I completed the picture in 3D and 2D view. Remembering spherical, at least for me, is mandatory doing at least 2 view in 2D. For example, let's do first XY and another 2D is maybe XC or YC. C you keep here in the verticals. Entonces I need to understand, pero no using my eyes, no. Using the triple integral que some students set out, but I understand que in the double integral part, que is this part in 2D, the the y value is in between 0 and square root 1 minus x squared. This is the job he's doing, these students. Yeah, I respect this. So you take this equation, que is y equal square root 1 minus x squared, square both sides, y squared is equal 1 minus x squared. Y I discover, wow, x squared plus y squared equal 1. This is a sphere. This is a sphere, radius 1. Okay, obviously, this sphere represents the intersection, that part, no? Okay. But the guy, this is the important moment, important moment. The guy que set out this integral is doing in this direction. Yes or no? And from 0, is this, to the circle, positive. Therefore, my region into the is no full circle, it's a quarter circle. Do you understand this part? And after that, he extending the strip in both directions from 0 to 1. Exactly happen here. X go from 0 to 1. Oh, entonces now I have a more clear idea about this solid, que es no full cone, no es ice cream, no. Okay, to understand a little bit more clear, maybe I'm doing another picture. I don't know si es necesario or no. We have the sphere. Remember the sphere. Okay, the radius is radical 2, no? However, the cone look like that. Okay. One more time, happy. One of these is radical 2, no? And this is 1. So this segment is 1. I suppose that this point is a point 1,1, the x of y. Again, phi is 45 degrees. Okay. Okay. Entonces, it's a lateral view looking in this direction. It's in my eyes. And we have another view for plan in this direction. This is my eyes. Get this. And they are complementary, you know. Okay, ready to set out the triple integral. 1, 2, 3.
Professors. For your 2D of the XY plane, why do you only highlight the region in the first quadrant?
Good question. The reason is because the guys que set out this triple integral, look at in this level, is doing from 0 to the y. This is a y. Y equal, look at that, y. Oh. Entonces this guy, I realize que is doing in this direction. And
yeah.
So extending, when you are doing the second part of the double integral from 0 to 1, different situation happen if you, for example, delete this 0 and you put -1. Do you understand this?
Yeah.
Si es -1, I open the window from -1 to +1. Entonces, same circle. Pero no. Entonces, you don't try mechanical. No. You thinking the information is given and you set out your own integral. Okay, let's try the spherical, no? Spherical, remember, the first level of the integration is rho square sine phi is the Jacobian. Okay, however, we have integrand function. Wow, we have integrand function, no? So integrand function we cannot write like that. No. I need to remember the formulas for a spherical. The formula is x equal, y equal, z equal. Spherical coordinate formulas. Rho sine phi cosine theta. Rho sine phi sine theta. Rho cosine phi. It's the formula for the conversion. Okay, entonces now I need to write x times y, que es rho square, another rho square, look, rho times rho, xy, sine square, phi, cosine theta, sine theta. Wow, what the hell? Okay, entonces actually, if you condensing this information in only one, it's a rho form, sine phi cubic, because we have 2 and 1, cosine theta, sine theta. Cool? I forgot the most important part, is d rho, d phi, d theta. Okay, entonces en the time que we have, well, no, stop. Let's continue next time. Next time I explain again this question. Okay, Guy, do you think that part is super complicated? Opinion. All right, let me
Not
use
horrible.